Welcome everyone, a warmful welcome everyone. And in today's session, we'll see about some searching techniques and how it works and what are the types of searching and how it involves in artificial intelligence and what's the process of it and some examples of that. Okay. Yeah, in recent years, there has been increased demand for software robots that perform internet searching, looking for answers to questions and for related information or for shopping deals, right? So the searching techniques consider internet as a graph of nodes, example like pages, and that is connected by links. Okay, this is how the internet searching uh, like connects everything. So it's basically as a software, as a demand of software and much more technologies. It's a kind of searching where we can look for the questions and the information or the shopping deals. Okay. And also the searching techniques consider internet as a graph of nodes, pages, and connected by links. Okay. As we seen in the previous video regarding the so many kind of toy problems and cues problems and eight puzzles. These are some kind of examples of search. Okay, searching. And similarly, now here we are seeing about the internet search. Okay, yeah, this is how the internet search works. And like it just considers the internet as a graph of nodes, like the pages connected by a link. For example, there is a book. Inside the book, there are so many pages, right? So that pages is known as graph. So that graph connected with the different kinds of links. This is how it works. Coming to different search algorithms. Search algorithms see like state, operator, cause, heuristic algorithm, no heuristic like informed search, uninformed search, LIFO, LIFO stack, FIFO queue, DFS, depth first search, BFS, breadth first search, CFS, cost first search. And from informed search, you may get best first search, problem reduction, constraint satisfaction, means and analysis, iterative deepening DFS, A star search, A0 star search, and these are some ways and different search algorithms used in artificial intelligence, right? So many algorithms have been used in artificial intelligence. Coming to this is one of the most important mind map you just want to remember, okay? Because it's played as well as your machine learning also. The search algorithm, there are two types. One is uninformed blind search, another one is informed search. What is this uninformed blind search or blind search? In the sense, there are the types under it, okay? So breadth first search, uniform cost search, breadth first also called as BFS, uniform cost search also called as UCS, depth first search also called as DFS, depth limited search also called as DLS, iterative deepening depth first search also called as LDFS, and bidirectional search. These are the various kinds of uninformed, okay, like uniformed search algorithm. Okay, a uniformed search algorithm includes BFS, UCS, DFS, DLS, IDFS, and bidirectional search. Okay, coming to informed search, it is best first search and A star search. Okay, so take this algorithm a pick of 2 minutes and you can go through this, and let's move on to next part. And yes, coming to search strategies in AI that helps you find, yes, search strategies may helps to find some solutions to problems by navigating through the state space, right? So these strategies can be divided into two main categories. One is uninformed and another one is informed, right? So this uninformed search involves BFS, DFS, etc. And informed search includes A-star search, greedy-based search, right? So yeah, now coming to the other thing like uninformed search strategies. These uninformed search strategies are nothing but are those that explore that state space and yes, without any addition information, right? So the common times that includes like the uninformed search strategies are those that explore that state space without any additional information or other than current state. Right? So the common types includes DFS. As I told, this DFS, that is breadth first research, explores all nodes at the current depth level. Before moving on to the next level, this will explore more and more. Okay, coming to depth first research, it explores as far as down a branch of search tree as possible before backtracking. This is how the DFS works. Coming to uniform cost search, it expands the node with the lowest path cost, ensuring the least costly solutions is found first. Okay, so we need to identify the least cost solution in uniform cost search. Similarly, the depth limited search, a variant of DFS that imposes a limit on how deep the search can go. Got it? It's a variant of DFS, so only it is called as depth limited search. It's a kind of DFS and that imposes a limit on how deep the search can go. Iterative deepening search. It combines the breadth first search completeness and depth first search space efficiency by performing the DFS repeatedly with the increasing depth limits. Okay, these are very most common types of uninformed search strategies. Okay, just go through these 2 minutes and we move on to the. This is the exact explanation of uninformed search strategies. And let's now moving on to the BFS. This first search is the most common search strategy for traversing a tree or graph. This algorithm searches the breadth first in a tree or graph. So it is called the breadth first search. And the breadth first search algorithm starts searching from the root node of the tree and expands all the successor node at the current level. So before moving to the nodes of next level, the breadth first search algorithm is an example of a general graph search algorithm. The breadth first search implemented using FIFO-Q data structure, right? So this is how the BFS works on. Coming to the advantages of the BFS, the BFS will provide a solution if any solution exists. And also, if there are more than one solution for a given problem, this BFS will provide the minimum solution. So that also requires the least number of steps. And if some disadvantages is there, no, it will moves on some kind of rectifications. So this BFS implemented using Q data structure, okay, because it travels entire graph and searches the breadth-wise, okay. That's what is known as breadth first search. Coming to the disadvantage, it requires lots of memory since each level of the tree must be saved into memory to expand the next level. This BFS needs a lot of time if the solution is far away from the root node. So it also requires the everything that every kind of things that there's a lot of time and the memory. So this is how the disadvantages. Make a look on it. We'll move on to the next thing. And yes, moving on to the tree structure, that how it looks as like the way that we has to represent is nothing but it like it's a below the tree structure. We have shown the traversing of a tree using the DFS algorithm from the root node S to the goal node K. Okay, there is a root node called S and there is a goal node named K. Okay, so BFS search algorithm traverses in a layers, so it follows the path which is shown by the dotted arrow. Okay, see here there is the dotted arrow, right? So this is how the BFS travels. Okay, in this way it travels from S to A, and from A to B, and from B to C, C to D, G, H, E, F, K, F, I, and K. Okay. Yes, S A B C D G H E F I K. This is how it travels from zeroth level to fourth level. Okay, from zero, this is the zero, first level, second level, third level, and fourth level. This is how it travels. Okay, so take a snapshot of this. It's also an important thing to remember. And moving on to the depth first search is a recursive algorithm for traversing a tree or data structure. Okay, it is also an algorithm that moves upon regarding the function of traversing a tree and the graph of a data structure. It's called depth first search because it starts from the root node. Why it's called as a depth first search? Because it's a simple thing that it starts from the root node and follows the each path to get its greater depth node before moving to the next part. Okay, so it moves on to the next part before knowing its greatest part. So that is why it is known as depth first search. Starts from the root because as usual it starts from the root node and follows the each path which is the greatest path node before traveling the next path. This is how DFS works. DFS uses a stacked data structure for its implementation. Uses the stack as the data structure for its implementation. The process of DFS algorithm is similar to the BFS algorithm. Okay, because the BFS uses the queue and the DFS uses the stack data structure for its implementation. Now got it right? It starts from root node and follows the each path to the greatest effect. Coming to the advantages, BFS requires a very less memory as it only needs to store a stack of nodes on the path from root node to the current node. This is how the BFS works. Similarly, it takes less time to reach the goal the goal node, okay, than the BFS algorithm. If it traverses in the right path, right? This is the disadvantage. And coming to like these are the advantages of DFS because it takes less time to reach the goal node than the BFS algorithm. And coming to the disadvantages, there is a possibility that many mistakes keep reoccurring. There is no guarantee of finding the solution. We don't think so that there will be finding of solution. So these DFS goes for a deep down searching, and sometimes it may go to the infinite loop. Okay, because these disadvantages include uh, there is no guarantee for finding the solution because there will be a solution, but that big concept will be a proper optimal solution. So there is one kind of disadvantage, and another kind will be like if algorithm goes for a deep down searching, and sometimes it may go to the infinite loop. Okay, this is how the DFS works as a disadvantage. Okay, yeah. Coming to the DFS architecture, like in the below search tree, we have shown that for flow of depth first search, and it will follow the order as root node, left node, and right node, right? So it will start searching from root node S and traverse A, then traverse B, then D, E. After traversing E, it will backtrack. That is why it is known as recursive. Okay, it will backtrack the tree as E has no other successor and still goal is not found. After backtracking, it will traverse node C and then G. Here it terminates as it finds the goal node. You can see here it's a kind of recursive algorithm. So here the backtracking of the data structure happens. Okay. So take a snapshot of this how it works and then we'll move on to the next thing. Coming to the BFS and DFS. BFS stands for breadth first research and DFS stands for depth first research, right? So BFS uses the Q data structure for finding the shortest path. Okay, it uses the Q, but the depth first search uses the stat data structure for building the finding the shortest path. And BFS can be used to find the single shortest path in an unweighted graph because in BFS we can reach a vertex with minimum number of edges from the source vectors or source vertex. Okay, that means you can use a single shortest path in the unweighted graph. Okay, weighted graph is nothing but there will be some arrow marks. Unweighted graph is you can't find the arrow marks and the path of it. Okay, because in BFS we reach a vertex with the minimum number of edges from a source vertex. Okay. Coming to the DFS, we might traverse through more edges to reach a destination vertex from the source. Okay. This is the main example, and we just wanted to know about the BFS and DFS, right? And coming to the next thing, like BFS is more suitable for searching vertices where which is closer to the given source. Okay, it's more suitable searching vertices which are closer to the given source. But coming to the depth first search, it is more suitable when there are solutions away from the source. Okay, this is how the BFS and DFS like difference most. Okay, coming to the next point, the BFS consider all neighbors first and therefore not suitable for decision making trees used in games or puzzles. because BFS will be the answer will be getting faster as well as the neighbors. Everything will be all neighbors first and therefore not suitable. BFS is not suitable for decision making. But DFS, right? So depth first search is suitable for decision making and suitable for games and puzzle problems. We make a decision, then explore all paths through this decision. So, and if this decision leads to win situation, we stop, right? Yeah, this is how it works. Coming to the time complexity of BFS, that is V plus E, when that is vertex plus edges. So when the adjacency list is used and we getting that O V square. When the adjacency matrix is used, where V stands for the okay for the adjacency list, the time complexity will be O of vertex plus edges. For the adjacency matrix, it will be O of V square. Okay. And the time complexity of depth first search is also similar to the BFS. Okay. Now you can go through this table. It's a very much important table. I'll giving you 2 minutes of time. Just go through this, and if you have any queries, you can comment me in the chat box. Yes, now moving on to the next thing, that is depth limited search. You can see here a depth limited search algorithm is similar to the depth first search. As I told, depth from the DFS, that is depth limited, depth first search, the DLS has been originated. With a predetermined limit, so there will be some limit in DFS. That is what it is named as depth limited search. Okay, and can solve the drawbacks of infinite path in the DFS. In this algorithm, the node at the depth limit will treat as it has no successor nodes further. Okay, so the depth limited search can be terminated with two conditions of failure. First one will be the standard failure value, and the second one will be the cutoff failure value. So the standard failure value, it indicates the problem that doesn't have any solution. Okay, the standard failure value indicates the problem which doesn't have any solution, but the cutoff failure value defines no solution for the problem within a given depth limit. These are the basic conditions for depth limited search. Got it? The first one is standard failure value. Second one is cutoff failure value. Standard doesn't have any solution, but the cutoff, it has no solution for the problem. Okay, this is how it varies. Coming to the advantages of depth limited search, depth limited search is memory efficient, right? So it is a memory efficient. Disadvantages are depth limited search also has a disadvantage of incompleteness, okay? Because we can't say whether the given problem is completed or not. Similarly, it may not be optimal if the problem has more than one solution. Okay, we can't be able to say that if the solution will be one or more solution. Okay, this is how it works. That is the disadvantage of depth limited search. Okay, take a snapshot of this. These are very important. Also remember the two conditions which stops the DLS. This is the flow of the depth limited search, like zeroth level, first level, second level, third level. It moves on. Okay, so it will use the limited kind of way. So it doesn't able to search the completeness. We can't say here the complete graph is searched because this is the one disadvantage of depth limited search. Okay, it only moves on to the particular way whether it founds the solution or not. Okay, this is how depth limited search works. And moving to uniform cost search, as I told, this uniform cost search is a searching algorithm that is used for traversing a weighted tree or graph. This algorithm comes into play when different cost is available for each. Okay, it's nothing but it's used for traversing a weighted tree or graph. Okay, while we traversing a weighted graph, then the uniform cost search will be one important thing. And this algorithm comes into play when a different cost is available for each. Because the primary goal of the uniform cost search is to find a path of the goal node, whether it has the lower cumulative cost or not. Okay. And the next thing will be it can be used to solve any graph kind of problems and to according to the path and what is the cost of their uh, root node or another thing. Okay, this is how it works. And coming to the next thing, can be solved whether the tree optimal cost is in demand or not. Okay, this is also a kind of thing. And the next one will be a uniform cost search algorithm is implemented by priority queue. This UCS is implemented by priority queue, right? It's a kind of queue. Okay, it's a kind of queue type, so it depends upon the this kind of algorithm, and it gives the maximum priority to the lowest cumulative cost. Okay, the uniform cost search is equivalent to breadth first search algorithm if the path cost of all the edges is same. Okay, it will be this UCS will be equals to the DFS while the cost of all the edges is same. Okay. Even if the edges are same, then it will be considered that UCS equals to the DFS. This is the important thing. Coming to the advantages, this uniform cost search is optimal because at every step the path is least cost is chosen. Okay. In every step we are doing, the least cost is chosen. Disadvantages is it doesn't care about the number of steps involved in searching and only concerned about the path cost, right? Due to which this algorithm may be stuck in an infinite loop. So I think that this is the one of the most disadvantages because it doesn't care about the number of steps involved in searching and only concerned about the path cost, right? So this is how it take and get stuck in the infinite loop. This is the one of the disadvantages. So take a snapshot of this uniform cost search and we'll move on to the next thing. Okay. Yeah. Coming to the uniform cost search diagram, you can see this zeroth level, first level, second level, third level, fourth level. This will move on to the weighted directed graph as the uh, path where the path is optimal. Okay. This is how it works. And yeah, coming to the next thing that is iterative deepening depth first search. It is IDFS. Okay, what does this IDFS means? It's nothing but it's an iterative deepening algorithm and is a combination of both DFS and the BFS algorithms. This search algorithm finds out the best depth limit and does it gradually increasing the limit until a goal is found. Okay, so this kind of algorithm performs depth first search up to a certain depth limit. Okay, and it keeps increasing the depth limit after each iteration, so until the goal node is found. Okay, so it just uh, tracks every goal node whether it is found or not. And coming to the next thing, that is this search algorithm combines the benefits of breadth first search, fast search, and depth first search memory efficiency. Okay, this is a combination of both BFS and the DFS memory efficiency. This iterative search algorithm is useful and uninformed search when the search space is large and the depth of the gold node is unknown. This iterative kind of BFS and DFS together, the IDFS, is very much needful if the search space is large and the goal node is, how to say, the goal node is unknown. If we don't know what is the goal and there are search space large, then we can find that IDFS is the best example. Okay. Coming to the next thing is advantages. Combines the benefits of BFS and DFS search algorithm in terms of fast search and memory efficiency. Okay. Coming to the disadvantages, the main drawback of IDDFS is that it repeats all the work of the previous phase. Okay, this is the disadvantages. When it repeats everything regarding the first part, then the time also lags and the memory also lags. So it repeats all the work from the previous phase. This is the disadvantage. Take a snapshot of the iterative deepening depth first search. We'll move on to the next part. And the next thing will be iterative deepening depth first search, right? The following tree structure shows the iterative deepening depth first search. This IDDFS search algorithm is used when the iterations does not find the goal node. Okay, and as I told, it doesn't. If the goal node is not found, then IDDFS has been used. First iteration will be A, and your second iteration will be A, B, C, and your third iteration will be A, B, D, E, F, G, and the fourth operation, like iteration, will be A, B, D, H, I, E, C, F, K, G. Okay, this is how you can see in every iteration A is repeated, and from second iteration B is repeated. This is how the iterative deepening depth first search works because it repeats all the kinds of goal nodes and the from the previous phase it goes on repeating. This is the big disadvantage of IDDFS. Okay, and just take a snapshot of this and we'll move on to the next thing. The final part of uninformed search strategies is the bidirectional search. Okay, what is this bidirectional search? It's nothing but it's a search algorithm that runs two simultaneous searches, one from initial state called as the forward search and other from the goal node called as the backward search. Okay, from the initial state from top to bottom, it is known as the forward search. For example, from bottom to top, then it is called as the backward search. So for these two searches are used in bidirectional search. The name itself you can see it's a bidirectional, right? What does this bidirectional mean? It's two kinds of directions will be used in the particular to reach the goal node. Okay, this is how it works. The next thing is bidirectional search replaces one single search graph with two small subgraphs in which one starts the search from an initial vertex and other starts from the goal vertex. Got it? This is how bidirectional search replaces. Okay. The next thing is the search stops when these two graphs intersect each other. Okay. It stops when the two graphs intersect each other. Bidirectional search can use search techniques such as bidirectional first search, like breadth first search, DFS, and DLS. Okay, these search can also use the techniques such as BFS, GFS, DLS, UCS, everything. So together combinedly also it can be used. Advantages: the bidirectional search is fast and the bidirectional search requires less memory. Okay, this is the advantages. Coming to the disadvantages, implementation of bidirectional search tree is difficult because it is a kind of both front direction and back direction. So implementation could be some difficult way. So in the bidirectional search, one should know the goal state in advance. Okay, this is also the disadvantage. We don't know where the goal is found, but also in that we should find the goal as an advanced state. This is how the bidirectional search happens here. Okay, just take a snapshot of this and we'll move on to the next part. So yes, coming to the workflow of the bidirectional search, in the below search tree, you can see that algorithm is applied here, right? So that is the bidirectional search algorithm. And this algorithm divides one graph tree into two subgraphs. So it starts traversing from node 1 in the forward direction and starts from the goal node 16 in the backward direction. So the algorithm terminates at goal 9, the goal node at the node 9, so where the two searches meet. This is how the bidirectional search works upon. So just go through this tree. And yes, now moving on to the backtracking search. It's a variant of depth first search called the backtracking search and uses the less memory. Only one user is generated at a time rather than all successors. Okay. So only O of M memory is needed rather than O of DM. Okay. This is how the backtracking search works on. So just remember it's a depth first search called backtracking search uses less memory and only one successor is generated at the time rather than all successors. Okay, so O of M is needed than O of BM. Okay, this is how it works. Coming to the searching with partial information, so different types of incompleteness leads to the three distinct problem types. Because in some way we can reach the goal node, but in sometimes we can't complete it. So the first thing is sensorless problems. If the agent has no sensors at all, that is known as sensorless problems. Contingency problem. If the environment is partially observable or if actions are uncertain, that is known as contingency problem. Third thing is the exploration problem. When the states and actions of environment are unknown, then that is known as the exploration problems. Okay. These are the three types of incompleteness that leads to the distinct problem types. Just go through all these kinds of types of incompleteness, which leads to the different separate problem types. Okay, just go through because this is the one kind of important thing. First one will be sensorless problem, that is conformant, and second one will be contingency problem, that is adversarial. And third one will be exploration problem. That is when the states and actions of environments are unknown. This is how it works, okay? And yes, coming to the next thing, searching with partial information. This is known as searching with partial information, right? So yeah, partial knowledge of states and actions. Okay, there will be some partial knowledge of states and actions, sensorless or conformant problem. Agent may have no idea where it is. Solution is a sequence contingency problem. So percepts provide you information about the current state. Solution is a tree or policy often interleave search and execution, right? This is how it works. If uncertainty is caused by actions of another agent, then adversarial problem, that is known as adversarial problem. Okay, nothing but percepts provide if the new information is provided about the current state, and the solution is a tree or policy that often interleave the search and execution. This is a contingency problem. And coming to the exploration problem, so I think that when states and actions of the environment are unknown. As we see, there are three distinct types of problems to identify the goal state, right? So here, the first sensorless or conformant problem is defined as the agent may have no idea about where it is and what this kind of solution will be. Okay, this is how the conformant or the sensorless problem happens. Okay. The next thing is contingency problem. Concepts provide a new information about current state. The solution is a tree or policy and often interleave search and execution. Okay. So if the uncertainty is caused by the actions of another agent, then it is known as mm, contingency problem. Exploration problem is nothing but when states and actions of environments are unknown. Both state and action are unknown, then it is known as exploration problem. Okay. Yes. Now, till now, we have been seeing about the uninformed search strategies. Okay. Like uninformed search strategies include BFS, DFS, uniform cost search, depth limited search, iterative deepening limited search, right? So these and all the things that we have been seeing in ununiform search strategies, right? And now moving on to the informed search strategies, right? So we'll see regarding the informed search strategies, how it works, what's the workflow, what are the types, and what are the disadvantages and advantages to be used. Okay, yeah. Now coming to the thing, informed search strategies. Okay, informed search strategies use the additional knowledge about the problem to make search process more efficient. They particularly rely on heuristics, which provide estimates of how close a given state is to the goal. Common informed search strategies include greedy best first search. Okay, that expands the node that appears to be the closest to the goal based on a heuristic. Okay, there are two types of informed search strategies. First is greedy best first search, and the second is A star search. Okay, A star search combines the advantages of BFS and greedy search by considering both the cost to reach the node and the heuristic estimate of the cost from that node to the goal. Okay, this is how it looks like. So the best and informed search strategies uses the additional knowledge to make the search process more efficient. Okay, and it depends upon the heuristic. The heuristic is nothing but just estimates how close the given state is to the goal. And the types will be the greedy best first search, and second one is A star search. Okay, this is how it happens. And coming to the best first search, the best first search algorithm always selects the path which appears best at that moment. Okay. The aim is to reach the goal from the initial stage via the shortest path, right? And the next thing is heuristic search. Heuristic best first search. It is an approximate measure of how close you are to the target. Okay, heuristic in the sense it's the measure of how close you are to the target and must be zero if node represents the goal state. If the node is representing the goal state, then the entire value will be 0. That is how the heuristic works upon, right? You got it right. The best first search is the algorithm that selects the path which is the best at that moment. For that moment, which is the best, that is used for best first search. And the aim is to reach the initial stage where the shortest path. Okay, if there is a shortest path, now then we reach the goal. Okay, that is how it works. Coming to heuristic, it's an approximate measure of how close you are to the target, and it must be 0 when it represents the goal state. Now coming to the greedy best first search, it's a combination of depth first search and the breadth first search. It's a combination of both best BFS and DFS. It's a greedy search algorithm. We expand the node which is closest to the goal node, which is estimated by heuristic function. As we told, the heuristic function is h of n. Here, the function f of n will be equal to the h of n, where h of n is the heuristic function. It estimates the cost from start node to the goal node. This is how the greedy best first search works on. Okay, and here will be the important diagram of that. Like function of n, f of n will be equal to the h of n when it reaches the and searches from node to the goal shortly. Okay, so just to go through all these concepts. Open, that is A is open, closed, B, BD in a sense it just moves A from A, it moves on to B, and in this direction it moves on to D. So that is BD. From B it moves on to the G, and from D it moves on to the H. Okay, so that's the thing. And from D, G, I, and D, G is there. Okay, so here similarly the information and the calculation happen. Just go through this part and we'll move on to the next thing. Yes, right. So coming to the last informed research strategies, that is A star search, right? So what is this A star search? It's nothing but you can see heuristic search h of n as well as the cost to reach the node, that is g of n. Hence, we can combine both costs as the following. So, combining the um, how to say this g of n and h of n is known as the sum is known as the fitness number, that is f of n. F of n is nothing but it's a fitness number. So, combined features of uniform cost search and greedy best search is known as A star search. In the function itself, you can see f of n equals to the g of n plus h of n, right? So, yes, the example where g of n will be the cost of path from start node to the node n, and h of n will be the cost of path from node n to the goal state, that is heuristic function. This is how A star search works upon. Coming to the function, like the explanation, you can go through this once again for A star search. Okay, for A star search, you can go through this. So yes, here is how it works. Like A star search, together of G of n and H of n. G of n from start node to node n, H of n from node n to goal state. Okay, this is how A star search works. Together, the sum is known as fitness number. So yes, now here the first module of the artificial intelligence is completed. Okay, Here, in today's session, we are seeing some informed search strategies and uninformed search strategies. In informed search strategies, we have been seeing two kinds of things: greedy best first search and A-star search. Right? This is how about the search strategies in artificial intelligence. Okay. Yes. Thank you.